Today we're going to discuss the esters, but before we talk about esters, let us remember first the alcohols. Alcohols is a family of organic compounds characterized by the presence of the functional group OH. The OH is attached to a carbon. Now, the first member is called methanol because it has one carbon only. The structural formula is when we see each carbon with what is attached to it after it. For the methanol, it is CH3OH. If you look at this formula, this is the displayed formula showing all the atoms and all the bonds in the compound. Ethanol has two carbons, so we have, here is the first carbon attached to three hydrogens, the second is attached to the OH. Remember, alcohols has only one OH, so it is called an alcohol. Now, propanol, again, one OH. Now, this is called, in reality, one propanol or propane 1-ol because the OH is attached to the first carbon. Just like we say this one is bute, it has four carbons, and the OH group is in the first carbon, so we call it butane 1-ol or 1-butanol. It doesn't make a difference where do I start. For example, if I have the OH group right here, this will also be 1-propanol. The starting of the numbering from the direction that gives me the smallest number to the functional group. Can I put the OH here in the second carbon? Yes, I can. But in this case, we call it 2-propanol because it is on carbon number 2. So to remember, alcohols, family of organic compound, it will end in OL. Functional group is OH. Meth is when it has one carbon. So the first member, methanol. Ethanol, 2 carbons. Propanol, 3 carbons. Butanol, 4 carbons. The second family we need to remember is carboxylic acids. The suffix of this family is oic, and the functional group is C-double-bond-O-OH. Don't be confused. Focus. In the alcohols, OH is attached to a carbon which is attached to other atoms, which is not oxygen. While in the carboxylic acid, OH is attached to a carbon directly attached to an oxygen with a double bond. So the functional group is the C-double-bond-O, OH as a whole. First member is methanoic, has one carbon, including the one in the functional group we included in the counting. So ethanoic acid, it has 2 carbons. One of them is the carbon in the functional group. Propanoic, it has 3 carbons. One of them is the functional group. Butanoic, 4 carbons. Again, one of them is the one included in the functional group. A second point to notice is that in the acids, the functional group is always on the side, while in the alcohols, like we said, it can be on the edge of the compound or it can be on one of the carbons in the middle of the alcohol. Esters are formed by esterification reaction, and this is a unique reaction between carboxylic acids and alcohols, where the functional group of the carboxylic acid, regardless of the chain, will react with the alcohol group regardless of the chain by removal of water molecule. This is catalyzed by the presence of concentrated sulfuric acid or an acid. It is called condensation reaction. We are removing a small molecule, which is water. Let us see how it works. The acid, for example, here I have ethanoic acid reacting with propanol. Ethanoic being 2 carbons. Propanol is 3 carbons with an OH. What's going to happen is that the hydrogen from the alcohol group will be removed with the OH from the carboxylic acid group to give me water. And the carbon double bond O in the acid will be directly attached to the oxygen in the alcohol to give me the new compound, which is the ester. Note here is how it works. The carbon from the acid, as it is no change. the carbon in the functional group, the one attached to the C double bond O, attaches to the oxygen in the alcohol, which is attached to the chain. After that, again, there is no change. This group is called ester linkage or ester group or ester functional group. C double bond O, O, and the O is attached to what is remaining from the alcohol. C double bond O attached to what is remaining from the acid. Another example I have here, ethanoic acid with ethanol. What do I get? I remove the OH from the acid with the H from the alcohol group. Note it has to be the H from the alcohol group, not any hydrogen. No, this particular H. And I get the ester. The ester is called ethyl ethanoate, and we'll see how did we come up with the name. And water is removed. Don't be tricked by the reversing of the order of writing the alcohol. I am always removing the OH of the acid from the H of the alcohol. Even if I see it in an equation like that, I remove the OH of the acid with the H from the alcohol, and then I stick the CO to the O and write the other end of the alcohol after that. If you look at the name, the rule is simple. In the name, we write the name of the alkyl group first, followed by the carboxylate group second. What do I mean by that? Let us see. If I have here this ester and I want to name it, I will split in the middle of the ester linkage like that. And the part of the O, as we agreed, comes from the alcohol. The part with the C double bond O comes from the acid. I start the name of the ester by writing the name of the alcohol first. How many carbons are there in the alcohol? 2. So it will be ethyl. It will end in "-ile". How many carbons in the acid? 1, 2, 3, 4. 4, so it is bute, and it ends in "-anoate", and the ester will be ethyl butanoate. Let us look at this one. Again, I'll do the same technique. I split in the middle of the ester linkage. The part with the O is the alcohol part, which comes first. The part of the C double bond O is the acid, which comes in second. The part of the alcohol ends in "-ile". The part of the acid ends in "-anoate". How many carbons in the alcohol? 1. So it is methyl. How many carbons in the acid? 3. So it will be propanoate. The name, I write the alkyl part first, the alcohol part first, so it is methyl, followed by the acid part, which is propanoate. Now let us look at this one. Propanoic acid reacting with methanol. So I'll remove the water and I will stick the C double bond O to the O. How do I come up with the name? I write the alcohol name first, ending instead of all, I will make it "-ile". It will come first. Second, I will write the name of the acid, but I will, instead of anoic, I will say anoate. And the name becomes methyl propanoate. And of course, water is produced, and this is catalyzed by sulfuric acid concentrated. If I look at the formula now and I want to deduce the name, pause the video for a second and try to deduce the name on your own before you play it again and hear the answer. Now, let us see. Same technique. Split in the middle of the ester linkage. The part with the O and the alcohol comes first. 1 carbon, so it is meth. And it will end in "-ile" because we changed the suffix to "-ile". The part of the C double bond O is the acid. How many carbons do I have? 1, 2, 3. So it will be prop. and we change the suffix to anoate. Now let us come here. Split in the middle of the ester functional group. Part of the O, this part is the alcohol. This part is the acid. Alcohol comes first, ending in "-ile". How many carbons do I have? 2. So it is ethyl. How many carbons in the acid? 2. So it will be ethanoate. Let us come here. Split in the middle of the ester functional group. Wait a minute. The acid here, the acid part here is on the right, not on the left. It doesn't make a difference. I can write the formula like this, or I can write it like this. The order in the displayed formula does not make a difference. The order in the name makes a difference. And the alcohol part must come first to be butyl. The acid part must come second, 1 carbon, so it is ethanoate. So in summary, alcohol part comes first, must in the name. Acid part comes second, must in the name. In the displayed formula, the order doesn't make a difference. In order for me to deduce, I split in the middle of the functional group. Now let us reverse the operation. How do I get the formula from the name? I will do the first one and then pause the video, try to solve the other 3 before you hear the answer. The very first step is that I will draw the ester linkage or the ester functional group. And after that, I'll continue my work. The first part of the name, ethyl. Yle is the alcohol part. How many carbons in the alcohol? F, which is 2. So I go back to my drawing. The part of the O is the alcohol. Missing how many carbons? 2 carbons, because it is F. Now let us go to the acid. Prop, which means 3 carbons in the acid. One of them is in the functional group, so I'm going to add only 2. And after that, I complete the hydrogens right here. And this is how we deduce the formula from the name. Now let us go to the other 3. I hope you paused and you tried to answer. We draw the functional group. And after that, the first part is the alcohol part. I have 3 carbons in the alcohol, so I go to the alcohol part, to the part of the O, and I add 3 carbons. I go to the part of the acid. It has 1 carbon, so it is this carbon, and there is nothing else, because this one is included in the name. I add my hydrogens to the drawings. Now, we'll do the same for the methyl butanoate. And I complete the hydrogens. I will leave you to draw the hydrogens. And right here, I will add propyl. So I'll add 3 ethanoate, 2 carbons. One of them is here, missing 2. And we add the hydrogens to the compound. Now I want you to think something. If I wanted to reverse the process, or not reverse, but ask you to deduce what are the compounds used in order to make this ester, or what is the name of the acid and the alcohol used to make this ester? You'll do the same thing. Ethyl is the alcohol, so the alcohol used here will be what? Ethanol. Propanoate is from the acid. What is the acid with 3 carbons? Propanoic acid. Here I have propyl methanoate. So the alcohol is propanol and the acid will be methanoic. Here, methanol from the methyl butanoic acid from butanoate. Last, propyl ethanoate. So it is made from propanol and ethanoic acid. Now, let us see how we can deduce the name from the structural formula rather than the displayed formula. Are we going to do anything different? No, we're not. we're going to do the same technique, meaning we're going to split in the middle of the ester functional group. How am I supposed to know it? In the structural formula, we always start with the acid. Always. The acid part is the starting part. And the alcohol part is the second part. Always, with no exception. The ester linkage is in the middle, and we're going to split in the middle of the two O's, which is the middle of the ester linkage or ester functional group. How many carbons are there in the alcohol? I have 2 carbons in the alcohol. So it will be ethyl, because in the name we always start with the alcohol, followed by the carbons of the acid. How many carbons of the acid? 2. So it will be ethanoate. Here, the alcohol part comes second in the structural formula, and the acid part comes first in the structural formula. Always. Reversing the name. The alcohol part comes first in the name, and the acid part comes second. How many carbons? 4 carbons. So I have butyl and propanoate. You can remember it by remembering that the functional group of the ester is C double bond O, and the O of the alcohol is attached to CH2, CH3, while this carbon, the one of the acid, is attached to another carbon which has hydrogen. In itself, it either has one hydrogen only or attached to other carbon. This can help you identify it. So, if you look at this question, he said that methanoic acid and propane 1-ol react to form an ester. The ester is going to be called propyl methanoate as a name, because the alcohol part comes first. It does not affect the answer, but I'm just saying it so that you guys remember. What will be the structural formula? The acid part comes first, the alcohol part comes second, and the ester linkage is in between. Methanoic means it has one carbon only, and this carbon is attached to hydrogen. So the acid part is this one. Therefore, the answer is A. What about this compound? I will split in the middle of the ester linkage. The part of the O here, the second part is the alcohol, so we used methanol, and the acid part, we used propanoic acid. So it is the opposite of this one. Here I split in the middle. Part of the O is the alcohol, it is ethanol, and this part of the acid, ethanoic acid. And here, this is an acid altogether, because COOH. That's the functional group of the acid. It is not an ester. And this is butanoic acid. So in summary, for the esters, for the name, alcohol part comes first. Alcohol part comes first, and the acid comes second. For the structural formula, the one that we have right here, the acid part comes first, and the alcohol part comes second. For the displayed formula, the one showing me the bonds, there is no specific order. And remember that you can deduce or remember that the acid comes first because the functional group written in the structural formula way is COO, with the carbon is the one for the C double bond. Thank you guys, and next time we talk about isomerism in esters. Have a nice day.